Have you ever looked up at the night sky and wondered what's up there besides the moon and the stars? Well, orbiting our planet right now are thousands of amazing machines called satellites. They are our eyes and ears in space, our guides on the road, and honestly, the reason you can watch your favorite show from the other side of the world. These incredible devices are some of the most important tools humanity has ever created. They work silently, high above our heads, making our modern world possible in ways we often don't even notice. Think about it. From the weather forecast you check in the morning to the phone call you make to a friend, satellites are involved. They are the unsung heroes of our interconnected world, working 24/7 to help us. Satellites represent a monumental achievement of science and engineering. Getting something to stay in orbit around the Earth is a big deal. It requires a deep understanding of physics, mathematics, and rocket science, but we did it. And ever since we launched the first one, we haven't stopped. We've been sending up more and more, each one more advanced than the last. These machines have completely changed how we see our planet and the universe. They have turned our big, wide world into a smaller, more connected community. They help scientists understand climate change, assist farmers in growing more food, and even help rescuers find people who are lost. It's a remarkable story of human curiosity and ingenuity. These orbital companions are more than just fancy pieces of technology. They are a symbol of our desire to explore and understand. Every satellite we launch is a step forward in our quest for knowledge. They carry our hopes and dreams into the vastness of space, allowing us to look back at our beautiful blue planet from a perspective that was once only available to astronauts. This new viewpoint has taught us so much about our home and our place in the cosmos. These high-flying robots are constantly gathering data, taking pictures and sending signals, all to make life on Earth better, safer, and more interesting for everyone. So let's take a journey together to explore these amazing machines. We will dive into what satellites are, how they got started, and the incredible things they do for us every single day. We'll look at the different kinds of satellites and discover how they power everything from your GPS to scientific discoveries about distant galaxies. It's a story that involves brilliant thinkers, daring engineers, and a whole lot of rocket fuel. By the end, you'll see that these orbiting wonders are not just far-off objects in space. They are an essential part of our modern lives, and a testament to what we can achieve when we reach for the stars. Consider this. When you hear the word satellite, you might picture a shiny, metallic object with solar panels floating in space. And you'd be right. That's what we call an artificial satellite, one that humans built and launched. But the definition of a satellite is actually much broader. In science, a satellite is simply any object that orbits or circles around a larger object in space. The force that keeps a satellite in its orbit is gravity. The larger object's gravity is constantly pulling the smaller object toward it, but the satellite is also moving forward at a very high speed. This forward motion prevents it from falling, creating a continuous loop around the larger body. It's a delicate dance of physics. The most famous example of a natural satellite is right in our night sky, the moon. The moon is a satellite because it orbits the Earth. Our planet's powerful gravity holds the moon in its path, and it has been circling us for billions of years. But Earth isn't the only planet with a moon. Jupiter and Saturn have dozens of natural satellites orbiting them, some larger than our own moon. Even asteroids can have their own tiny moons. These natural satellites are fascinating worlds in their own right, and studying them helps us understand how our solar system was formed. They are the original satellites, showing us how orbital mechanics work on a grand cosmic scale. Now let's talk about the ones we built. Artificial satellites are human-made machines launched into space to orbit Earth or another celestial body. To get into orbit, a satellite must be carried up by a rocket that travels incredibly fast, at least 17,500 miles per hour. That's about 28,000 kilometers per hour. At that speed, the satellite can achieve a balance between its forward momentum and the pull of Earth's gravity. It's like constantly falling toward Earth, but always moving sideways fast enough to miss it. This is why satellites don't just fall out of the sky. They are in a state of continuous free fall around our planet. So why do we need them? Well, being high above the Earth gives satellites a unique advantage. From their vantage point, they can see large parts of the planet at once. This makes them perfect for all sorts of jobs. They can relay communication signals over long distances, monitor weather patterns as they develop over oceans, provide precise location data for navigation, and take detailed pictures of the Earth's surface for science and security. Without these artificial satellites, our world would be a very different and much less connected place. They are our robotic helpers, tirelessly working from the ultimate high ground. The idea of putting an object into orbit is not new. It actually goes back hundreds of years. The first person to really think about it scientifically was Sir Isaac Newton way back in the 17th century. He imagined a cannon on top of a very tall mountain. If you fired a cannonball, gravity would pull it to the ground. If you fired it faster, it would travel farther before landing. Newton reasoned that if you could fire the cannonball fast enough, it would travel so far that it would actually circle the entire Earth, constantly falling but never hitting the ground. This thought experiment perfectly described the basic principle of an orbit. For a long time, this was just an idea, a dream. But in the late 19th and early 20th centuries, brilliant thinkers started to figure out how we could actually make it happen. A Russian schoolteacher named Konstantin Tsiolkovsky is often called the father of cosmonautics. He developed the theoretical groundwork for space travel, calculating that multi-stage liquid-fueled rockets were the key to reaching space. Around the same time in America, Robert Goddard was building and testing the world's first liquid-fueled rockets. These pioneers laid the scientific foundation, turning Newton's dream into an engineering challenge that seemed possible to solve. Their work inspired generations of scientists and engineers. The dream finally became a reality during the Cold War, a period of intense rivalry between the United States and the Soviet Union. This rivalry sparked the space race. On October 4, 1957, the world was stunned when the Soviet Union successfully launched the very first artificial satellite, Sputnik 1. It was a simple, polished metal sphere, just 23 inches in diameter, with 4 long antennas. As it circled the globe, it transmitted a simple, repeating beep-beep-beep signal that could be heard by radio operators all over the world. This little beep was a monumental announcement. The space age had begun. The launch of Sputnik 1 was a huge wake-up call for the United States. In response, the US scrambled to catch up. Just a few months later, on January 31, 1958, they launched their own satellite, Explorer 1. This satellite was not just a beeping sphere. It carried scientific instruments that made the first major discovery of the space age, the Van Allen radiation belts, layers of charged particles held in place by Earth's magnetic field. This marked the beginning of using satellites not just for prestige, but for incredible scientific discovery. The race to the stars was on, and it would forever change our relationship with space. Satellites are like the ultimate multitaskers, and we've designed different types to do all sorts of important jobs. One of the biggest jobs is communication. Communication satellites act like giant mirrors in the sky for radio signals. A signal is sent from a ground station up to the satellite, which then amplifies it and beams it back down to a different location on Earth. This is how we get live international television broadcasts, long-distance phone calls, and internet access in remote places like airplanes and ships. These satellites have connected the farthest corners of our world, allowing information to travel across oceans and continents in an instant. Another crucial role is weather forecasting. Weather satellites are our watchtowers for the atmosphere. They constantly monitor the Earth, taking pictures of cloud formations, measuring temperatures, and tracking the movement of powerful storms like hurricanes and tornadoes. By providing this information in real time, these satellites give meteorologists the data they need to make accurate forecasts. This early warning system is incredibly important. It gives people time to prepare for severe weather, evacuate if necessary, and ultimately helps save countless lives every year. Without weather satellites, we would be almost blind to the large-scale weather systems developing over our oceans. Then there are the navigation satellites. If you've ever used a GPS on your phone or in a car to find your way, you have used a navigation satellite system. A network of these satellites, such as the Global Positioning System, orbits the Earth, each one continuously broadcasting a precise time signal. Your GPS receiver on the ground picks up signals from at least 4 of these satellites. By calculating the tiny differences in the time it takes for each signal to arrive, the receiver can pinpoint your exact location, latitude, longitude, and altitude, anywhere on the planet. This technology has, honestly, revolutionized travel, logistics, and exploration. Finally, we have science and Earth observation satellites. These are our robotic explorers and environmental guardians. Some are telescopes, like the Hubble Space Telescope, that look outward to study distant stars, galaxies, and the origins of the universe, free from the distortion of Earth's atmosphere. Others look inward at our own planet. They monitor deforestation, the melting of polar ice caps, changes in our oceans, and air pollution. They help farmers manage their crops more efficiently by showing which fields need water or fertilizer. These satellites provide the critical data scientists need to understand and protect our planet's fragile ecosystems. It's easy to think of satellites as something distant and abstract, something only for astronauts and scientists. But the truth is, you probably use satellites every single day without even realizing it. Think about your morning routine, the weather report that helps you decide whether to bring an umbrella. That data came from a weather satellite. The morning news show with a live report from another country, a communication satellite made that possible. Even the time on your smartphone is likely synchronized using the incredibly precise atomic clocks aboard GPS satellites. They are the invisible infrastructure of our modern world. Satellites play a massive role in keeping us connected. In our globalized world, being able to communicate instantly across vast distances is essential. Satellites provide the backbone for international phone calls and television broadcasts, linking continents together. They also provide a lifeline for people in remote or rural areas where it's difficult to build physical infrastructure like fiber optic cables. For ships at sea, planes in the air, and researchers in Antarctica, satellites are often the only way to connect with the rest of the world. This connectivity supports global business, fosters cultural exchange, and helps families stay in touch no matter where they are. One of the most important jobs for satellites is helping in emergencies. When a natural disaster like an earthquake, flood, or wildfire strikes, it can destroy communication lines on the ground. In these situations, satellite phones become the most reliable way for first responders to coordinate their rescue efforts. Earth observation satellites can also provide before and after images of the disaster area, helping authorities assess the damage, identify the hardest-hit locations, and plan the most effective response. They can help locate people who are lost in the wilderness or at sea by picking up signals from personal locator beacons. Satellites are truly lifesavers. Beyond emergencies and communication, satellites support our economy and learning in countless ways. They help make agriculture more sustainable by allowing for precision farming, where water and fertilizer are applied only where needed. They help shipping companies track their cargo across the globe, making global trade more efficient. They enable scientists to share huge data sets and collaborate on research from different parts of the world. And for students everywhere, satellite imagery and data provide an incredible tool for learning about geography, environmental science, and astronomy. They bring the world and the universe right into the classroom. The satellites of today look very different from their early ancestors like Sputnik 1. Just like computers and phones, satellites have undergone a massive technological evolution, becoming smaller, smarter, and much more capable. The first satellites were huge, weighing thousands of pounds, and cost a fortune to build and launch. They were built with the technology of the 1950s and 60s, which meant they had limited capabilities. Their main job was often just to prove that they could work, sending back simple signals or basic data. They were the pioneers that paved the way for everything that followed. Over the decades, thanks to the revolution in microelectronics, satellites began to shrink. Engineers figured out how to pack more and more power into smaller and smaller packages. This led to the development of small sats and CubeSats, which are tiny satellites, some no bigger than a loaf of bread. These smaller satellites are much cheaper to build and launch, often hitching a ride into space, along with a larger satellite. This has democratized access to space. allowing universities, small companies, and even developing countries to launch their own satellites and conduct their own research. It has led to an explosion in the number of satellites orbiting our planet. Modern satellites are also incredibly smart. Many are now equipped with advanced onboard computers and artificial intelligence. This allows them to process some of the data they collect right there in space, instead of having to send all of it back to Earth. They can make decisions on their own, like adjusting their cameras to focus on an interesting event, such as a volcanic eruption or a wildfire starting. This makes them much more efficient and responsive. Furthermore, improvements in solar panel technology and battery storage mean that modern satellites can power themselves for much longer, often operating for 15 years or more. Another huge change is the way satellites work together. Instead of just one big, powerful satellite doing a job, we now often use constellations of many smaller satellites working in coordination. Think of a navigation system like GPS. It requires a whole network of satellites to function. Newer constellations, like those for satellite internet, involve hundreds or even thousands of small satellites in low Earth orbit. These satellites fly in formation and pass signals to one another, creating a seamless web of coverage around the entire globe. This new approach is making services like high-speed internet available everywhere on the planet. So, what does the future hold for our orbiting companions? Get ready, because things are about to get even more exciting. One of the biggest changes happening right now is the creation of massive satellite internet constellations. Companies are launching thousands of small satellites into low Earth orbit to provide fast, reliable internet to every corner of the globe. This could be a game changer, connecting the billions of people who still lack reliable internet access. It could transform education, healthcare, and economic opportunities for people in rural and remote communities worldwide. Imagine a world where everyone has access to the sum of human knowledge. Looking further ahead, satellites will be essential for the next era of space exploration and even space tourism. As we plan missions to return to the Moon and go on to Mars, we will need a network of communication and navigation satellites around those celestial bodies, just like we have around Earth. This lunar GPS would help astronauts and robotic rovers navigate safely. For space tourism, satellites will provide the communication links to keep space travelers connected to their loved ones back on Earth. They will be the invisible support system that makes living and working in space possible. Satellites will also become even more integrated into our lives on Earth, helping to build the smart cities of the future. Imagine a city where traffic flow is managed in real time by satellites that monitor congestion, automatically rerouting cars to avoid traffic jams. Satellites could monitor air quality block by block, manage energy grids more efficiently, and help coordinate autonomous vehicles like delivery drones. They will provide the high-precision data needed to make our cities safer, cleaner, and more efficient places to live. They will be the central nervous system of a smarter planet. In the end, the journey of satellites is a story about human curiosity and our endless drive to connect, explore, and improve. From a simple beeping sphere to vast constellations of intelligent machines, satellites have fundamentally changed our world. They connect us, protect us, and help us understand our place in the universe. They are a powerful symbol of what we can achieve when we work together and aim for the stars. The next time you look up at the sky, remember the thousands of unseen helpers orbiting above, working tirelessly to make our world a better place. The future is up there, and it's brighter than ever.